Hey guys, I'm just going to go straight into 5.2. So we're just talking about what to do if when you're trying to finish something, the exponent of the base is negative. You cannot answer with an exponent that is a negative number. So this is just going to go over what to do about that. All right, so negative exponents, and the other word in this description is division. So when you have a negative exponent, you are going to need to involve division in creating a positive exponent. All right, so if we were to simplify x to the power of 2 divided by x to the power of 5, if we review the exponent rules that we already know, right? X to the power of a times x to the power of b is x to the power of a plus b. X to the power of a divided by x to the power of b is x to the power of a minus b. Anything to the power of 1 or 0 is 1. What else do we talk about? The power rule. So x taken to the power of a, and then x to the power of a taken to the power of b, denoted by parentheses, is x to the power of a times b. Helpful to put parentheses around those because when you're entering them into XYZ math, you need parentheses for both the A and the B to be up there. Otherwise, it'll just take A, and then you'll be back down at the bottom with the big letters again. Good? So if we were to apply, which rule can we apply to this situation? X squared divided by x to the fifth, that would be the quotient rule, right? So that becomes x, your numerator, minus your denominator. So that would be 2 minus 5. 2 minus 5 is a negative 3. So this is what we're talking about today, negative exponents. If you have a negative exponent, what you need to do is change the position of the variable. And if you move it across this line that is a division bar or the fraction bar, your exponent gets to become positive. So x to the power of negative 3 is the same as 1 over x to the power of positive 3, right? Because anything divided by 1, right? Let's just use the number 9. 9 divided by 1 is 9. So if I have an exponent like 9 squared, even 9 squared divided by 1 is still 9 squared. Good? So x to the negative third is the same as x to the negative third divided by 1. 5 to the power of negative 2 is the same as 5 to the power of negative 2 over 1. You can put anything over 1. It doesn't change the value. It just turns it into a fraction that you can now work with, okay? So x to the power of 2 divided by x to the power of 5 is x to the power of negative 3, because 2 minus 5 is negative 3. X to the power of negative 3 divided by 1 is the same as 1 divided by x to the power of positive 3. Now, if we didn't know these rules up here, I could also just do this in a more long form fashion. X squared divided by x to the fifth. X squared is just x times x. X to the fifth is x times itself 5 times. Okay, and then what do? Those are all multiples. Those are all being multiplied, so we can get rid of anything that is a multiple or a factor on both the top and the bottom. So both of those x's were eliminated on the top, and on the bottom we have x times x times x. When you are dividing or multiplying, you don't put a 0 when you've eliminated all of your multiples. You just put a 1 as a placeholder. 1 divided by x times x times x, or 1 divided by x to the third. Good? Which is the same answer we got when we subtracted 2 minus 5 and moved it across the fraction bar. Okay? So the negative exponent rule sounds complicated, but Negative exponents indicate a reciprocal or change of position for the variable. X to the power of negative n is the same as 1 over x to the power of positive n. Similarly, if the negative exponent is in the, this is, remember, the numerator, this is the denominator. Here it's in the numerator, right? Here it's in the denominator. If the negative is in the denominator, we do the same thing. We move it across the fraction bar, across the division bar, and it becomes positive. So 1 divided by x to the power of negative n is the same as x to the power of negative n. X to the power of negative n is the same as 1 divided by x to the power of positive n. Only the bases with the negative exponents get flipped. Okay? Here we have x to the negative 7th, y to the 11th. Y to the 11th is not moving because that exponent is positive. The negative exponent is only associated with the letter right next to the negative sign. This -4 is not associated with the 3. It's only associated with the x, all right? But that's what we practiced with 5.1, okay? Simplify. Oh, sorry. Second note is changing the sign of the exponent has nothing to do with the sign of the base. X didn't change. X remained positive or negative. Only the sign of the exponent changed. All right, x to the power of -2. I'm going to put it in fraction form just so I can see it better, and then I'm just going to flip it across the fraction. It's now in the numerator. I'm going to put it in the denominator. Once it's in the denominator, the exponent changes signs. Okay, there's nothing on top now, so I'm just going to put a placeholder of a 1 on top. Or I can say I turned it into a fraction and then I flipped the whole fraction. Y to the power of -3 is the same as y to the power of -3 over 1, which becomes 1 over y to the positive 3. Because I want this negative to become a positive, I do that by moving it across the fraction bar, just like I did up here. Across the fraction bar, across the fraction bar. Good. 3 to the power of -2. To the power of -2 over 1. And then I've created the fraction. Now I move it across the fraction bar. 3 to the power of 2. There's nothing up here, so it's a placeholder. 3 squared is 9. 3 to the power of -2, 0.11111. 1 divided by 3 to the power of 2, same. 1 divided by 9, same. X squared divided by x to the 4th. Again, you're welcome to just say that's 2 x's on top and 3 x's and a y on the bottom. No, 4 x's on the bottom. Eliminate common x's. X squared on the bottom. There's nothing on the top. It's not a 0. It's a placeholder 1. Good. 7 or, so that's one way to do it, or the way I'm supposed to be teaching you, x squared divided by x to the 4th is x to the power of 2 minus 4, which is -2, and then I move it across the fraction bar. I create the fraction bar, and I move it across it, whichever way you prefer, depending on how big those exponents are, right? So 1 divided by x to the -3rd. It's already in fraction form, and this is a negative exponent, okay? Not the base. The exponent is negative. If I want it to be positive, move it across. Now it's on the top. There's nothing on the bottom, so I'll put a 1, okay? Same here. I want this -4 to become a +4, so I have to move it from the denominator into the numerator. Ooh, sorry, I didn't even pick up on that. So now we just call it y to the 4th. And here we just call it x to the 3rd. We don't need that one. I'm catching on. Next, we have 1 divided by 4 to the power of -2. Welcome to put it in your calculator. 1 divided by 4 to the power of -2. They give me 16. It's a negative exponent, so I want it to be positive, so I'm going to move it across the fraction bar. 4 to the power of 2. There's nothing down here, so I can add a 1, or I can just notice that it doesn't need a fraction because it's all in the numerator. If it's all in the numerator, there's nothing in the denominator, it's a whole number. 4 squared is 16, which is what my calculator said. Good. All right, number 10, we are now moving on to, a situation where there are two different bases. We have a base of 5, and we have a base z. Good? Those are separate. So that is 5 times z to the negative 2. The negative 2 is only with the z. All right? I want this to be a positive exponent. And again, we said we can't leave negative exponents in our final answers. So that's why we're just learning this trick for 5.2. Change a negative exponent to a positive, move it across the fraction bar. So now it's down here. I don't need that 1. 1 times z to the power of 2 is still just z to the power of 2. But that 5 didn't come with me, so now it's 5 on top. The base 5 stays on top because it had no negative exponent. But the z moves to the denominator because it had a negative exponent that I wanted to make into a positive exponent. Good. 11 here is just negative 5 to the power of negative 2. Remember, we are only worried about the negatives in the exponent, okay? We are not worried about the negative associated with the 5. Also remember that negative 5 to the power of negative 2 and negative 5 to the power of negative 2 are two different problems, okay? This does not have parentheses, so if it had parentheses, it would be negative 5, all included, right? 2 negative 5s, except it's negative, so it would be 1 over. This is a terrible example. All right, let me start over. Negative 5 to the power of negative 2 would become, I'll move it across the fraction bar. Negative 5 with the parentheses to the power of negative 2. I would move it across the fraction bar. It only gets rid of that negative, not that negative. And then it's negative 5 to the power of 2. So negative 5 times itself 2 times, right? Twice gives you a positive 25. However, negative 5, no parentheses, to the power of negative 2. First step is the same. Move it across the fraction bar. Here, however, we have a negative not associated with the 2. 5 times 5 is 25, but we still have that negative out in front. So all we're working on today is the negative exponent. The exponent rules apply to the negative in the base the same way. If it's in parentheses, treat it as a negative number being multiplied by a negative number. If it's outside the parentheses, treat it as a negative sign outside of the multiplication of the two numbers positive form. Good. Maybe one more. Negative 2 to the power of 3 is negative 2 times negative 2 times negative 2, whereas negative 2 to the power of 3 is negative 2 times 2 times 2. Or if you prefer. Good. Oh, and when it's an odd number, it actually ends up being the same. Don't love that example. Should have thought of that a bit better. negative 2 to the power of negative 4, negative 2 to the power of negative 4. Good. The first thing we're going to do is change this negative to a positive by moving it down here. So negative 2 quantity to the power of negative 4 is 1 divided by negative 2 quantity positive 4, which is same here, but we're not including the negative when we multiply it. So same first step. I want this negative exponent turned into a positive. Flip the fraction, create the fraction and flip it. This negative sign is gone. This negative sign still exists. Okay. Tangent. So negative 5 to the power of negative 2, no parentheses. Good. Turn it into a fraction. Move the negative exponent and its base to the other side of the fraction bar. If there's nothing up here, a 1. Now, 5 times 5 is 25, but there was a negative in front of that 5. Negative in front of the 5, negative in front of the 5. It's not in parentheses, so it's not going to be negative 5 times negative 5. It's going to be negative times 5 times 5. 1 over negative 125. Negative 5 to the power of negative 2. Or 1 divided by negative 25. Same answer. Good. All right, here we have x to the power of 6 divided by x to the power of 8. I've used up a lot of space. I will solve this one over here. X to the 6th over x to the 8th. Again, you can do 6 x's divided by 8 x's. Placeholder, because you eliminated all of them. How many x's do I have left? 2. So perfectly legitimate way to find the same answer, or you can say x 6 minus 8 is x to the power of 6 minus 8 is x to the power of negative 2, which is turned into a fraction. Flip the fraction. Same answer. Here. X to the power of negative 2 divided by x to the power of negative 7. Again, I want that negative exponent and its base moved so that it's a positive exponent. This negative exponent and its base moved, so it's a positive exponent. Good. Or you can say x to the power of negative 2 divided by x to the power of negative 7 is x to the power of negative 2 minus negative 7. And we know minus and negative becomes a plus, right? Negative 2 minus negative 7 is positive 5. Sorry, couldn't see that. Negative 2 minus negative 7 is positive 5. So you can flip them around. so that everything's positive and then do your subtraction, or you can subtract a negative from a negative and see if the answer it gives you is a positive and you can be done. Good. For 14, only the top of the fraction, only the numerator has a negative exponent. So 14 is x to the negative 7th over x to the 3rd. You need to, as your first step, move. I mean, no, you can do it a different way. But what we want to do, what we have practiced doing, is moving the base with the negative exponent across the fraction bar. So it already has a fraction bar. You already have something in the denominator. I need to move the one term in the numerator down to the denominator, and I get, right? But there was already something here. Seven times 3, when the bases are the same, it's just 7 plus 3. Good. So negative 7, I wanted it to become a positive 7, so I moved its base across the fraction bar. Now it was x to the positive 7, and there was already an x to the positive 3 down there. We are multiplying two bases, the same base with different exponents. We can add the exponents and we get 11. Or, so I said you have to move this. You don't have to move it. You can say it's x to the power of negative 7 minus 3, right? Because we take our numerator and we subtract our denominator. Negative 7 minus 3 is a negative. Oh, guys, I added 7 and 3 wrong. 10. So if you subtract negative 7 and negative 3 correctly, you get negative 10. That's embarrassing. Now it's a negative. You need to move it, make it into a fraction, move it across the fraction bar. Now it's a positive. Good. All right. So that one would be 1 over x to the positive 10. 15. Remember, you are only worried about a base with a negative exponent. We have a base of 3. We have a base of x in the numerator. In the denominator, we have a base of 2 and a base of x. Only one you need to worry about is the one with a negative exponent, okay? Leave everything else the same. 3 times x to the negative 4th divided by 2, you can't even see this. I'll start down here, times x to the positive 4, okay? Again, we are only worried about moving this one. 3, that one's moved. 2, x to the 4th was already there. When I move this one, another x to the 4th. Because it was x to the negative 4th up here, it's x to the positive 4 down here. So that is 3 divided by 2 times x to the power of 8. Good. All right, here we need to move this x to the negative 7. We need to move the x to the negative 2, and we need to move the y to the negative 2. Y to the 11th, x to the negative 2, y to the negative 2. All right, let's start moving them, okay? This one has a negative exponent, so I need to move it down. You can do them all at once if you want, or you can do it one at a time. So now we have y to the 11th on the top. And on the bottom, we have x to the negative 2, y to the negative 2, and then we moved x to the negative 7th, so now it's x to the positive 7th. Okay, I've moved that one. That one's now positive, and that one's now positive. Halfway there. move whichever one you want to next. Oh, sorry, couldn't see that. Good. All right, now we get, it was a negative, now it's a positive. Y to the 11th. Because it's just been up there the whole time. Y to the 11th, Y to the 11th, Y to the 11th. Down here, we still have Y to the negative 2. And we have X to the 7th. Shouldn't be writing them out of order like that. XY, 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 YX. Boo. All right, well, I'm moving it anyway. Last one to move. So up here we have X squared times Y to the 11th times Y squared divided by X to the 7th. Good. Now you have some like terms that you can multiply. These bases are the same. Y to the 11th times Y squared is Y to the 13th X squared X to the 7th. Good. Move it down here. So we said that that was Y to the power of 11 plus 2 times X squared over X to the 7th. 11 and 2 is 13. So I'm going to say X squared Y to the 13th, because I'm supposed to try and keep it in that order, divided by X to the 7th. Our Y's are taken care of. Now I need to subtract X squared minus X to the 7th. X to the negative 5th, shouldn't have moved everything. Y to the 13th, but that's okay. That one's negative again, just a bunch of correct. Y to the 13th over X to the 5th. Good. All right, there were different ways to do that. Like we could have, when we had X to the negative 7th, so this is the original one, Y to the 11th divided by X to the negative 2, Y to the negative 2. You can just take your like terms, like bases, and say this is X to the power of negative 7 minus negative 2. And then this is Y to the 11th minus negative 2. And that becomes X to the power of negative 5, Y to the power of 13. We move that X down and we get Y to the power of 13 over X to the power of 5. So there is more than one way to do it. Those are 2 ways to do it. Thanks guys. Have a good day.